So, yeah, hello everyone. Welcome to my YouTube channel. Today I'm going to discuss about data model in Python. So, let's start. So, data model in Python. So, in Python, everything is an object. Now, what do we mean by object? An object is actually a physical entity. Means if we say a physical entity, so consider an suppose there is an example like we have a pen, we have a chair, we have a laptop. So these are objects. So when we say this is an object, these are physical entities, we can see them. So like it has some values, it has some properties, so that's why it is called an object. Suppose your laptop is of rectangular shape, it has some depth, it has some breadth, it has a length, it has one screen, it has keyboards. So all these are attributes of these laptop. So we can say this laptop is an object having some attributes. Similarly, in Python also, everything is an object. Whatever we write in Python, everything is an object. So even the code, what we write in Python, this is also an object. So let's consider an example. Like this is a Python program. We are going to write one function def f, and these are some lines. This is another function def f. These are some lines inside the functions. So each line, each code will be an object. So here def f, all these will be an object, and these will hold a physical memory in the computer. So we can say this function, this f, this is an object, this will be an object. Likewise, we can say objects are Python abstractions for data. So what do we mean by that? So consider this Python program. We write some data in it. So what are the data? The codes are the data. So we can say the object as abstraction of the data, whatever we will understand, like what we will understand it more thoroughly. So first, object. So please remember, everything in Python is an object. What if you write some class also? So class A, then here goes your code, this def f, here your Python code goes. So this will be an object, this will be an object, everything will be an object. Just consider this in mind. So please remember this thing in mind. So let's now go further inside the object. So this object means this class, this function, this is considered an object. So now in Python, each object has three different attributes. One is the identity, another is the type, another is the value. Now I'm going to explain each one by one. So identity is the address, nothing but the address of the code or object, means where this object is stored in computer, in memory. The address means its location. So suppose we have written this class A. Now this class A will be stored somewhere. Where it is going to store? Suppose this is class A. Now this class A will be stored in some address. Consider, for example, this address is 123.789. So this will be an address. This is called an identity. Now type. Now type is, this is a very important concept. So this is an interview question also. Like what is a type of an object, means what does it signifies. So type actually signifies what are the operations we can perform on an object. Suppose this, for example, I'm going to a write a equal to 1. Now this a will be an object. This a is an object. So now what is the value of this object? The value of this object is 1. For consider this 1, and this 1 will be stored in some memory location 1 2 3 5 6 7 8. Now this is the identity. This is the identity, and type will represent, this is an integer type. So in integer type we can now as I said, type actually defines what are the operations we can perform on that object. So in an integer, what are the operations we can perform? Addition, subtraction, multiplication, like this. So these are the things which actually return, the type will actually tells you what are the operations we can perform. But consider a is equal to some list. Now a is an actually list. Now what are the operations we can perform on this list? We can find the length of this list. Now see, this is we can also say it is a sequence. This sequence containers, because it list can hold multiple elements, like different kind of objects. So we will come to this later in another videos. But consider a is equal to some list. Now length of the list. Now what are the type? Now what the type will return? The type will return the operations that we can perform on the list. Now length of the list will be 1. Append will be 1. We can add one more element at the end of the list. Append. Now delete an element from list. So these things we can perform. These are the operations which we can perform on the list. So when we check the type of this, and then the type will show that it will be a list, and we can actually know that these are the operations which we can perform. So basically type will return what kind of object it is. So suppose if you type in your Python interpreter, then it will type, when we type a, in this case it will show as a int class int. And always have you noticed the type will show always this as a class, and this is an int. So we will come to it later, but now simply remember that type will return the what type of class, what type of object it is, and what type of operations we can perform on it. And this type a, it will show a class list. So this is class list. Okay, so this is a very important concept. Now how just remember this command, type, then inside a parenthesis the object. Then we can get to know what type of object it is. Tells the operations and type of object. Now what is the value? Now value is the value it actually holds. In here, in this case, 1 is the value, and here in this case it is sequence, and the values are 1 2 3. So this these are, so value actually represents what value actually it holds. Now there's a very important concept called mutability and immutability. Now we will understand like what is mutability and immutability in Python. Now consider based on this value, whether we can modify or we cannot modify, objects can be divided into two types: mutable and immutable. Mutable are those objects in which we can change the value, but immutable are those objects which we cannot change the value. Okay, so this is a very important concept. So just please remember, mutable is those objects which we can change the value, and immutable are those objects which we cannot change the value. Now a equal to 1. Now and a is a tuple. Now okay, before going to the let me tell you what are the immutable and mutable objects. Now mutable are those which we can change. Now let's understand what are the mutable and immutable. So mutable are list, dictionary, byte arrays, set. This list, then set, all are sequences. This dictionary is a mapping. We say it is a mapping because it is a key value pair, so that's why it is called a mapping. So these, and so for example, let's define one list. 1 is equal to 1 2 3. Now we can do this operation: list 1 is equal to 3. Now if you print the list 1, then it will be 1 3 and 3. Okay. Now immutable are those, for example, integer, string, frozen sets, tuples. So let's consider T1 is equal, T1 is a tuple, 1 2 3. Now T1 0 is equal to 3. This operation you cannot do because tuple are immutable containers. You cannot assign a value to a tuple. But T1, how about this one? 1 2, then 1 2 3. T1 2 0 is equal to 7. T1 equals to 1 2. Now when you print this, it will be 7 2 3. Now why we can do that? Because this list is a mutable container, mutable sequence, mutable container of sequences. So that's why we can change the value of this list. This is possible, but this is not possible. So sorry, this will be possible, this is possible, but this is not possible. Now for example, a equal to 1, b equals to 1. Now based on this mutable and immutability, there is a very important concept. This is an interview question, so please remember this one. Please focus on this concept. Important interview concept. A is equal to 1, b is equal to 1. A is equal to, this one is list, this one is another list. Now how the memory will be created? So when the Python code encounters a is equal to 1, so 1 will be created and a will be pointing to this one. Now when it comes to b is equal to 1, it will not create another 1 as a separate object. It will keep this 1 and it will make this b point to 1. Why this happens? Because 1 is an immutable. So all the immutable objects in Python actually tries to optimize the memory creation. Now consider a is equal to one list, b is equal to another list. Now here what happens actually? Now a Now in this case, in memory, in list, the memory management and the object allocation happens in a different way. But for as of now, we will keep it in very simple. Consider this list is an object which has one memory location. Now, when it will encounter this line B, it will not assign this B to this object. It will create another list and it will keep on pointing. The b will keep on pointing to this. Why this is so? Because lists are mutable container sequences. So that's why this memory allocation happens in two separate objects. So please remember this one. In immutable objects, it will point to the same object, but in mutables, it will be a different allocation of memory. So this is a very important concept. So please remember this one. Now a equals to 1, b equals to 1, c equals to 2. Now a will be pointing to 1, b will be pointing to 1, c will be pointing to 2. Now if we want to prove this, now how we are going to prove? We can simply use id of a, id of b, id of c. Now id of a and b will be same because it is pointing to the same object. So suppose this 127 and 128. Now id of a will be 127, id of b will be 127 and c will be 128. Okay. Now if a equals to none, b equals to 1, c equals to 2. Earlier what was it? Earlier a was pointing to 1, b was pointing to also 1, c was pointing to 2. Now in this case what will happen? A will be pointing to a none object. And this one will get removed. This link will be removed. Now b equals to 1. Now b will keep on pointing to 1. C equals to 2. C will keep on pointing to 2. So this is a very important. Thanks for watching my lectures. Please subscribe to my channel to get more updates on Python courses, and I'll be covering more in-depth Python tutorial. So I am following the documentation of python.org. Thank you.